Okay, welcome back. Again, my name is Everell Morris from NetMerge, and I'm your instructor for the AZ Azure 900 Fundamental course. We're going to be looking now at chapter 3 of 6 in the Azure course outline. So, we're going to be talking about Internet of Things, IoT. So, we're going to be talking about things like the IoT Hub, IoT Central, IoT Sphere, and then I'm going to move on, and then we're going to be talking about describing and examining analytic services such as Azure Snaps, Hadoop Insight, and then Azure Databricks. We're going to be taking a look also at Azure Fabric and Azure Logic Apps. We're going to be talking about functions. We're going to be talking about machine learning, cognitive service, and Azure Bot Services. We're going to be talking about, I mentioned this serverless computing with function and logic app. We touched on that before briefly. I'm also going to be talking about DevOps, where it came about, the DevOps pipeline, and the different tools that we could use in DevOps. We're going to be talking about GitHub repository. It's now a Microsoft product. We're going to be talking about GitHub Actions, Actions for short, and then we're going to be talking about Azure Dev Test Labs and the different features that you would have access to in Azure. So let's get started and let's start talking. Now, IoT Basics. Let's talk about Azure Internet of Things, IoT. IoT is a managed cloud service that is currently connected to a lot of devices globally. You could use it to connect, monitor, and control billions of IoT devices at any given time. As it is right now, Azure has millions, billions of IoT devices that are connected to Azure and are controlled by Azure worldwide. IoT is a connection of any electronic devices or endpoint to Azure over the internet remotely for any particular monitoring services, updating services, for whatever reason. But there are resources that are controlled from a centralized point using Azure IoT services. Now, there are three Azure IoT services, and we're going to go through the three different services and what the each services are capable of doing. Now, at the most basic level of an IoT device, it must have a circuit board and a sensor because sensoring or measuring is at the core of what Azure is all about. So it will measure things like sound, it will measure like light using infrared light, it would measure height using a form of measurement, a rule. It will measure speed using a speedometer. It will measure smoke using a smoke detector. You could do ultrasound. You could measure temperature, motion. You could measure tilt, gases. Again, I spoke about smoke already. Accelerometer, we could use that. It could measure flow. It could measure arrow. It could measure pressure. It could measure alcohol. And there are so many things that you could measure and read and react to from a IoT device. So those are just some example of the different things that you could measure in Azure. Now, Azure has three core services, actually four core services, and we're going to look at all of them. Now, the first one is the IoT Hub. It's a central messaging service. It's at the bottom of the IoT resource pool, and it's used for bi-directional communication between IoT application on the device that it manages over the internet. So there's bi-directional two-way communication going on between a IoT hub and the actual device. And the device is anything with a circuit board. Now, Azure IoT Hub can deliver reliable and secure communication with telemetry, monitoring, file sharing, and request response method to control your device. It can also route messages to other Azure resources. You can use IoT Hub to fully control your device remotely over the internet in Azure. Now, Azure IoT Central is the second service. It has everything that you get in IoT Hub, except it's more intuitive with our overlay dashboard that sits on top of the IoT Hub. So, this is IoT Hub with a graphical user interface. You could use it to connect, monitor, and manage IoT device the same way you could do in the Hub, but again, with the visual dashboard, you get that extra capability and that extra management feature. It can also aggregate surveillance over all devices with alert notification parameters that you can even push updates from your command central. So the extra capabilities, you get a visual overview, you get a visual dashboard, you could aggregate surveillance over all the devices, you can push notification and get notification, and you can use it to also push updates to these devices. So again, it's a more a more comprehensive form of control. Next, we have the IoT Sphere. Um, I'm sorry, IoT Central. This is just one more piece. IoT Central allows you to fully manage your devices, and it's a lot quicker to set up with plenty support and starter templates. So that's just an additional feature. You have starter templates, and it's saying that it's a lot easier to set up than the IoT Hub. Now, the next piece of Azure we're going to look at is the IoT Sphere, and this is a more comprehensive IoT solution. So this would have everything that IoT Hub and IoT Central has, but with more flair or more control to it. In critical situations, like for example, an ATM machine where security is paramount and the identity of the device is also required, so you're not just trying to monitor or to manage the device, you also concern about the integrity and the identity of the device. You need to be able to identify the device that you're dealing with in a situation as critical as an ATM. The Azure Sphere has built-in end-to-end communication and security in place to deal with this type of situation. So that's the Azure Sphere. It comes in three parts. First, you would have a board, which is a microcontroller unit board, which would be used for the identity that I spoke about. Then you would want a Linux operating system. That's a traditional operating system that you would find on electronic device all over the globe. Then you would have the Azure Security Service, which is the third layer, which would help you with security, and we'll talk about the different type of security. The Azure Sphere uses Security Service AS3 to ensure the device was not tampered with maliciously or it is not compromised physically in any way, shape, or form. Now, each device in the Sphere must be authenticated using certificate-based authentication. Now, the IoT Edge is the fourth piece, and it is a fully managed service that allows data analysis model to be pushed directly to the IoT device, which allows them to react quickly to state changes without needing to consult cloud-based AI model in Azure. So what I've done, I've gone through the different pieces of IoT solutions that you would have. We talk about the IoT hub. You would use that on basic machine. Let's say, for example, your refrigerator. You just need to find out alert when it needs servicing. Very basic, not critical. You would use the IoT hub. The IoT central you would use for a more up-to-date information that you would like visualize. Let's say for example you're monitoring a homeowner premises and you're using surveillance and you're using sensors for motion detection. You want to be able to visualize that so you could react to it because you're providing a security service right there. Now for IoT Sphere, if you're doing mission critical things, say for example you want to check the temperature for flight for aircraft, or you want to monitor something as critical as an ATM, or it could be a medical machine that a patient is wearing, then you need the IoT Sphere because you get more real-time control and more functionality over that device. And then when you put them all together, you have the IoT Edge that you could use for analysis service. So understand that IoT services are very broad. You could use it in a lot of different industry, almost any industry you can think of. You could use it with almost any device. You could use it with your DPS. You might use it with your temperature sensors to get temperature from a particular location. You might use it with your infrared light. You might need to sense a particular gas. You might need to use it with your smoke detector. You might want to use it. I mean, there are a lot of different reasons why you could use an IoT device. So you get an understanding of the different types of IoT devices, the different type of IoT services. What you need to remember is that the IoT sphere you need to have a electronic communication going on with the board. So you would have to have the microcontroller installed in the device that you need to communicate with as a method of authenticating that device to know that it is actually the device that you want to be talking to and dealing with, as in the case of a ATM machine. So you get a general understanding. There's another part of IoT I want to talk about that I saw in the exam that was not in the course outline, and it has to do with Windows IoT services. Now, this deliver enterprise manageability and top-notch security for IoT solution. The Windows IoT Enterprise is a member of the Windows 10 family, allowing organizations to create their own Internet of Things with secure devices that can be quickly provisioned, easily managed, and seamlessly connected to an overall cloud strategy. So when we're talking about OEM devices, we're going to see how this plays into the overall picture of managing devices. Now, if you're building any kind of OEM style appliances, such as a point of sale, a retail device, industrial automation equipment, digital storage, digital signage, medical equipment, or any appliance with a screen, Windows IoT service is the solution for you. So it's telling you that you must have a screen in order for this to work out for you. So that's a solution provided with Windows 10 IoT Enterprise Services. Now, a good example of a IoT is like a kiosk that you would see. You would go to like your motor vehicle department and you have to print a ticket based on the type of service you want. You get those kiosks. It talks about a point of sale. Those are two good examples of IoT devices that you would be using in an OEM manner. So there's a lot of ways you could use IoT devices, and Windows 10 IoT Enterprise come with the capabilities and features already built in to manage those applications for you. You could build them into your OEM products during manufacturing, so that service is there for you. I want to mention it because, again, I saw it on the exam and I didn't see Windows 10 IoT Enterprise anywhere in any of the course outlines. So that's a part of the service, and I want to bring it to your attention. Now let's move on. Let's look at Azure Snaps. We're going to be looking at analytics service now. Now, Azure Snaps morphed the best of SQL Server enterprise data warehousing technology into Spark technology, big data technology, and Data Explorer for logs and time series analytics. I'm going to cut that part, that sentence, and I'm going to bring in another part of Azure that I want to talk about. Now, the Azure Synapse Analytics is an infinite analytics service that merges data integration, enterprise data warehousing, big data analytics under one umbrella. So this brings to bear limitless analytics as a serverless or dedicated service at scale inside Azure. So there's a mouthful right there. It is a serverless solution. It can run at scale, and it works with big warehousing, big data to bring you infinite analytics services. And that's the part I want to touch on when I spoke about the morphing before and the SQL Server Enterprise data warehousing. That is the data warehousing I wanted to talk about. So I talk about that first. Now, if you go back to the exploration for the pipeline, you get ETL out of it and ELT and deep integration with other Azure services such as Power BI, Cosmos DB, Azure Machine Learning, and all of those incorporate into Snaps. So, from my understanding, Microsoft is posturing Azure Snaps as the solution for analytics. So, let's take a look at it from a visual perspective and get an understanding of how it works in a visual setting. So, this is the actual diagram. This is Azure Snaps Analytics at work. You're getting the Azure preview, the Azure Machine Learning as a feature. This is your business Power BI working as well. and you're able to get an overall view of what it looks like. This would be your machine ML Studio running. This is Snaps Analytics. This is your on-premises data center. This is your cloud data. This is your software as a service data, your Office 365 data. This is your real-time streaming data. It goes into the data integration. You have management, you have monitoring, and you have security. And here are the analytics runtime that you could merge your service, your analytics snaps with. You have the SQL data warehouse, you have your Apache Spark, and you have your data explorer, and you also have your Azure Data Lake Storage Gen 2. So these are massive data solution for handling big data that you could use Azure Snaps with. And again, it is limitless analytics service that binds together enterprise data warehousing and big data analytics. So the freedom to query serverlessly and with dedicated resource at scale. I don't think it gets any better than that as it relates to analytics. But let's take a look at some other solutions that are available. Now, there's the Azure Hadoop Insight. If this is what you're familiar with and you've worked with Hadoop, it's very powerful. It's a cloud distribution of Hadoop open source component. Hadoop Insight is the name, HD for short. It's Azure HD Insight. It's managed, it's a full managed analytics service, full spectrum analysis service, and it's available in Azure at the enterprise level as well. Now, the Azure Hadoop is a great solution for moving massive amount of data into customizable environment. It is also very user friendly, fast, and it's less expensive, I take it, than the Snap services. One of the core key features you want to look at is the fact that it's able to do mapping and move into a customizable environment for you. So that might be a plus for you. Or if you're coming from the Hadoop background and that's the service you want to use, that's your solution supported in Azure. You can also use Azure HD Insight in conjunction with highly popular open source frameworks such as the Hadoop framework, Sparks, Hive, LLAP, Kafka, Storm, R, and many, many more. So again, it's very portable, it's very scalable, and there's a lot of support for the Hadoop Insight as well inside of Azure. Now, Azure Insight process massive amount of data with managed clusters, and it uses the Hadoop cluster inside the cloud. So there you go. You have a second service that you could use for your analytics purposes inside of Azure Hadoop. If you have the experience and the knowledge, then you can bring it over and use it inside Azure. Now let's take a look at Azure Databrick. It's an Apache Spark based analytics service that integrates with data services in Azure and other open sources. So let's take a look at some of the features. Azure Databrick offers three environments for developing data intensive applications. So these environments are Databrick for SQL, Databrick for science and engineering, and Databrick for machine learning. So Databrick for SQL is a very user-friendly analytic platform to run SQL queries on their data lake. It creates multiple virtual visualization types, and it built and shared dashboarded, so it's very easy to use with your Azure SQL database features. Now, Databricks Science and Engineering provides an interactive collaborative platform for engineers as big data pipeline. Raw data could then be ingested through Azure Data Factory in batches or in stream, real-time stream using the Apache Kafka. So it supports the same thing as Hadoop, and it also could use Event Hub or even IoT Hub. We just spoke about the IoT Hub. It's like a basic, the most fundamental service in Azure for IoT. This data lands into a data lake for long-term persistent storage, and you could manipulate those data for analytic services. So there you go. That's your analytic services in Azure. You have Databrick, you have Snaps, and you have Hadoop. Now let's take a look at machine and deep learning in Azure under the artificial intelligence banner. Now, AI is a robust service in Azure that allows application systems to perceive their environment and develop adaptation to meet business end goals. The primary goal of an AI solution is to adapt implicitly without being explicitly coded to respond to information driven system. So what that is saying, you need system that could adapt systematically to changing environment without you explicitly writing code and instruction telling it what to do, which is what a developer normally does. So machine learning is supposed to grow and adapt to automation as it learn and it matures. Now AI has two unique models: machine learning, which is a technique that uses data science on existing data for forecasting future data behaviors and prediction outcomes and trends. Now, you have also deep learning systems that simulate the neural network of the human mind, or try to simulate the neural network of the human mind to learn and grow from exposure and experience. So there you have it, machine learning. It's an Azure Service toolbox where data scientists and machine learning engineer can find tools that they can use to automate and effectuate their day-to-day workflow. You can use ML to develop, train, test, deploy, manage, and track machine learning models. Machine learning is also auto-tune self and tweak, auto-tune or tweak self, making your model more robust and shrewd. Machine learning project requires a team with varied skill set for solution lifecycle. Azure Machine Learning adds shared notebook, which is a different service in Azure, compute resources, data, and environment tracking and auditability to their preferred UI ML Studio. So you would use ML Studio to do your development, your ML development. It requires a specific skill set and it uses past information and knowledge to simulate future responses to changes in your environment. So that's machine learning. Now let's take a look at the overall concept. This is machine learning. This is your data that you would ingest. You would train the model that you create, that your data scientist would create. You would deploy the model. You would monitor it and see how it's performing. You would analyze performance and keep retraining the model, updating the data, the raw data that initially comes in, and then it would keep going. It's a cycle, end-to-end cycle, until the product or solution is retired. So it's always training, always learning, always going. Again, ML Studio is a development workspace where you can integrate ML into your application with pre-built algorithm and data handling modules. So your machine learning, it needs specific tools, you need special skill set. Within the ML, you can create a model in Azure Machine Learning or grab a pre-built open source platform such as services from PyTorch, TensorFlow, or Scikit-learn. Those are examples of tools that you could help to use develop your machine learning models. But again, just remember that for machine learning, you need a great deal of skill set, you need specific tools, and you need expertise within the field to help train and make your model get better and better. In the end result, it should adapt to changes and it's supposed to implicitly make decisions on its own once the model is mature. So that's machine learning. These ML ops tools help you to monitor, to retrain, redeploy models. The UI uses to support for Python. You should get support for Python, SDK, Azure Resource Manager, REST API, and CLI version 2. So those are a good overview of what you would need to actually adopt and implement machine learning as a solution in Azure using those tools and resources. Now let's take a look at the solution that is supposed to emulate human neurals. Now, Azure Cognitive Service. Simply put, it's a collective of AI services that allow you to construct cognitive solutions such as seeing, hearing, speaking, understanding, reasoning, and even decision making. So this actual service, cognitive service, are mostly REST API and SDK libraries. So it requires right up front, even though it implies that it's going to emulate human neurals. These are predefined, prepackaged solution, API plugins, RESTful APIs, side SDKs library that you would incorporate into your application. So technically, it would be a lot easier to include these type of services into your application, even though it would on the front seems like it would be more intense. So with the cognitive services, they're easier to implement. All you need it would be the APIs and the libraries to as plugin. So that can help you develop cognitive intelligent based solutions now a lot quicker. So these this makes it a lot easier to infuse AI into your application without having deep engineering skill like you would need in ML in the subject matter. So this is deep learning at work for you in Azure. I want you to understand the difference between the two. ML requires a lot of skill set and engineering, a lot of data and deep learning. I'm sorry, and learning and adaptation. With AI, you're able to emulate seeing, hearing, speaking, understanding, reasoning, and other services using RESTful API. So your speech to text or text to speech services like that, the ability to identify, do biometrics and stuff like that, those type of things, the ability to take orders and make decision and respond to question, all those type of things are good examples of machine learning. All right, so let's dig some more into, I'm sorry, good examples of deep learning. Now, the catalog of cognitive services that provide cognitive understanding is categorized into five main pillars. So let's look at the cognitive pillars. I mentioned them briefly: vision, face recognition, or even to read a driver's license and auto update. So if you're working with services such as Lyft or Uber, they have so many drivers that they have to deal with. You're able to update your driver's license to a lot of services, and it will, extricate the information it needs from the driver's license, including your picture, and tell you if it is sufficient or not. You could do face recognition on Facebook and Instagram, and even assign name to an image. You could identify a image and put a person name to it. That's where the technology is at. Now, speech. I spoke about text to speech. If, for example, Fidelity Investment, if you should call them the first time when you set up an account, after that they would refer to you by name, because once you start talking, the person on the other side understand that is you. Good morning, Mr. Morris. How are you doing? They know it's you without asking you, could you provide me your name? Could you tell me who you are? No, they got past a lot of that information using the speech recognition technology that we're talking about. Now, language, natural language is built in to normal conversations. You could do Q&As, you could answer a lot of questions, get your account balances, get update, get the last five transactions. You could get a lot of questions and you could talk to a lot of these services and they're able to respond to you accurately without having to deal with any humans at all. So that's a language. Now let's look at the decision and knowledge piece. Computer determining if your driver's license has the correct picture and data required. Yes, it could look at your driver's license and decide that it expired and could tell you that they cannot accept it. Same thing with your passport or any form of ID. So it is able to do a lot of decision making cognitively using these types of services. So let's look at the final pillar, and that is search. It applies to machine learning, to the web searches. So it actually piggyback on the actual machine learning part of AI to actually provide services for you over the internet where you can actually search for things in a cognitive manner. So there are the five pillars you have. You get an understanding of the cognitive services in AI. You understand the machine learning, and you should be able to differentiate between machine learning and deep learning or cognitive learning. Okay, so let's move on. We're going to be talking now about Azure Bot Service solution. Now, this is probably the least explained service in Azure ecosystem. There's not a lot of information about it, but understand Bobs provide an experience that feels very personal and highly intuitive and can respond intelligently to a lot of services. Now, bots are famous at banks for pre screening and capturing profile information before assigning your call to a real person. You could use them for reservation or routine tasks that you want to do on a repetitive basis. So, bots need no human intervention at all to fully execute a task if they're great bots and they're well mature in the specific arena that they're serving. Now, in general, an end user converses with the bot using text, speech, etc. And this could be a quick Q&A or deeply intense conversation that require responses. So they will understand text and it will understand your voice and it can also respond to it. So unlike cognitive or ML services, bots are learned resources that you can offload common repetitive tasks to and not have to worry about manually handling tasks. The bots can handle the task for you accurately. So now you have the third piece of the AI that you could understand. You understand what the cognitive is, the machine learning, and now you're getting an understanding of what the bot services are able to do. Okay, serverless computing is what we're going to be talk about next. So let's get started. Okay, so let's get started with serverless computing. Now, serverless computing has to do with functions and logic apps as the most common two types of serverless computing. There are plenty of serverless computing, but these are going to be the two most common ones that you have to encounter. So, serverless computing enables developers to build applications faster by eliminating the needs for them to manage infrastructure resources. With this platform as a service solution, serverless application in the cloud can rely on cloud service providers to automatically provision, scale, and manage the infrastructure required to run those codes. So we understand what serverless computing is. At this point, we have talked about it before briefly. Now we're going to look at it in more details. So, in understanding the definition of serverless computing, I want you to understand it's very critical that servers are still running in the background in platform as a service. It's just that you will not, as a developer, have to deal with those provisioning and servers. So, servers are running, but you don't have to deal with them. So, serverless computing is what Microsoft refers to it as. Now, the approach enables developers to concentrate on business logic and solution delivery, increasing productivity, product delivery, and optimizing the use for human resources. The cloud service provider simply handles the infrastructure for you at that level, and you're able to focus on doing what you do best, which is writing code, testing code, and doing your job specific role. So you won't have to worry about the environment or waste time configuring network or resources for a network. Now let's look at functions. Explain what serverless computing is for you in a nutshell. So let's take a look at functions in more detail. So function is a very critical pillar in Azure Serverless Computing Solution Framework. These small chunks of codes are usually used to respond to routine events, oftentimes a REST request, and we're going to be looking at one, a timer, or a message from another services. If you're coming from a development background, functions or methods, if you're coming from a Java background, should be familiar to you. It's a probably the smallest bit of code that you could write to actually do something. They're task specific, they focus on a specific task, but it's just a simple snippet of code. Now, the difference between what functions do in Azure and what they would do in a programming language is that you don't need an IDE, which is an integrated development environment, or a text editor to actually use functions in Azure. Everything you need is provided for you. You just need to create these code snippets or the scripts, and the functions are able to run and execute and perform as they would using a development environment. Now, functions in Azure, they run as small code, like I mentioned. You could bring your own skill set if you're from a C sharp background, a Java background, JSNode, JavaScript, Python, or you could even use PowerShell or CLI to actually create your functions in Azure. So it's a really powerful feature. We're going to take a quick look at it in the portal. We're going to create a quick function so you get an understanding and a feel as to what functions are. It's a good part and a good point to get your hands and feet wet in Azure. Now, functions are mostly used for event-driven triggers, so it responds to an event, a button press, a mouse click, schedule tasks, things like those. It responds to a event, and you can use it to respond rapidly to an application or service as well. So they are stateless solutions that toggle into state mode when you need them, and they'll go back to a stateless solution once you don't need them. And this is good to understand because this is the rationale behind you paying for compute time when you execute a function. You're not paying for the function when it's sitting lying in state. You're only going to pay for the function when you use it, when you activate it, and you're going to pay for compute time when you actually run that particular function. Now, with these microservices, I am going to go into microservices when we talk about Azure Fabric. We'll talk about that more, but with microservices, you get agility, you get micro billing for your compute time. I just mentioned that. And microservices are really small bits of code that are client centric, they're task specific, and they're focused on a specific task. Now, if you're coming from a developer background and you're familiar with terminologies such as solid and design principles, functions would be similar to the S in the solid principle, the single responsibility principles, because it is only focusing or it's only placing emphasis on a single task, a small snippet of code just to do a simple calculation, one single task. It does it real quick. That is microservice, that is function, and that is a good way for you to understand it. And finally, you could write code and don't have to worry about the framework. Like I mentioned, you don't have to worry about the environment that it's written in. Once you're a developer, you could write your script using many different language and computing resources. You could actually work with it inside. So this is designed for programming in mind. It's for developers, and that's why it is used at the platform as a service level, and that's why it is also serverless computing. So once you hear serverless computing, remember functions, remember logic app, and remember platform as a service. It's very important that you understand those two terminologies. Now, what I want to do, I want to take a quick look at the functions in Azure, and what I'm going to do, we're going to go into the Azure portal like we did before. As soon as we start typing, you see the Azure login. I'm going to click at it. We want to make sure we're going into the Microsoft Azure portal and nowhere else. You always want to pay attention to that. I'm going to sign in. Remember, I already have an account. My goal is to give you a feel as to what it entails to create a function in Azure, and it's coming up. And what I'm going to do, even though it says function app right there, I always tell you, you want to learn to type in and search, get familiar with typing and searching for what you need. So even though it's in front of my eyes, I want you to get familiar with it. So we're going to create a really quick function and show you how simple it is to use a function in Azure. Okay, so first you want to select a subscription. Remember, you need a subscription to use Azure. We spoke about that before. Whether it's a paid subscription, a postpaid or prepaid subscription, you need a subscription to be able to use Azure. So I'm going to use a generic subscription that I already have, and then I'm going to select a resource group, and I already have a resource group for the AZ900 fundamental, so I am going to use that particular resource group. Now we're going to create a name for the function, and we want the name to be unique, so I am going to call it the AZ900, and I'm just going to refer to it as our underscore function. Okay, so the name is unique. Let's see if it is. No, it's not. So it's not taking that name. You have to have a unique name. All right, let me do this and see if that is a better solution. Okay, it takes that name, and we're going to be running code. We're not doing a Docker container. Now it says runtime stock, and this is where you get to choose your background. So I'm from a .NET background, so I am going to choose .NET, so I could do this in C#. If you're from a Java background, you would choose Java. Now I'm going to do review and create code, and it should be creating that resource for me. All right, it's validated. Now I click the create button, and if you look, the resource is being created. That was exceptionally fast. It's still running. Okay, good. So the resource is created for me. Actually, it is still running here. You see where it says deployment in progress? It does take a little time from time to time, but you could see it's already creating some of the resources that we need. Okay, again, it's still running there. These things could take a moment at times. Okay, excellent. So the resource was created now. So it asked me if I want to go to the resource, which is exactly what I want to do. So I'm just going to navigate over to the function that we create, and we call it our function. Just remember, that's what we call it. So what I'm going to do now, I'm going to use up the quick start template that we spoke about. It asks you if you want to start with a code editor. No, because we want to demonstrate that you could do this absolutely with no integrated environment or coding editor in the background. So I am going to click on this. Okay, and I'm going to say create, meaning we want to create a function, and I'm going to be selecting one of the predefined ones that are in your code base. And what I'm going to do, I'm going to just select a HTTP trigger as a predefined function that is out there, so we could see it, that you could use a predefined template. It's creating the function for me. So this is an HTTP trigger that's supposed to trigger a function when we make a HTTP request through the web browser. Okay, so let's look at the code. We're going to go to the code and test it. And again, I just want to demonstrate how easy. Now, you could see everything is created for you. If you're from a C# background, it applies all the using statement for you. All you would need to create a class for you, an asynchronous class. And you have the body, it's going to be extracting the name. And we're going to run this function just to give you a feel of what it looked like in test mode so we could see. So you just want to go to the top and just run this function as it is. And I'm going to say run without doing anything. Then we're going to modify it and run it again. And you see how easy it is to use this code. So it's connecting. Okay, boom. There's the result. It says, hello Azure, this HTTP trigger function executes successfully. So if we look at this is the output. What we're going to do, we're going to input our own parameter. And I'm going to say now Azure AZ 900. And I'm going to say our function. And you're going to see this incorporated in the result as well. And we're going to run it. And your output should include that in your output. And boom, there it is. It says Azure AZ 900 function, and it's done. So I'm demonstrating to you how easy it is to go into Azure and create a function to actually run an executable task. And I'm showing you using a predefined HTTP request function. So each time we make an HTTP request, this function would be triggered and this would be your response and result. We could change it to do much better things or much more meaningful things in Azure. The purpose is just to demonstrate to you how simple it is to implement a function in Azure and actually use that function to execute a particular task. So I'm finished with this resource. I'm gonna want to get rid of this resource. So I'm gonna actually delete this resource because I don't need it any at all. So let's see if we could find this function. It's called our function, and I'm gonna click on it, and we're gonna try to delete it together. So what I'm gonna do, and you probably will realize why I did this really soon. I'm gonna delete this function. I'm gonna click on delete. It's gonna ask me to confirm deletion. So in order for me to confirm deletion, I'm gonna have to actually input the function name as it is. So what I'm doing to save time, I'm just gonna copy and paste the function name, and I'm just gonna say yes, and I'm gonna delete this function because I don't want this resource to be lingering out there because I don't need it. And if I do a refresh, it says deletion. This function should be gone once I refresh my resources. Okay, so that's it. That's what I wanted to show you so you could get an understanding of function. So let's get back to the course and let's move on. You get an understanding of what a function is and how it works. Now, here I just want to run over the some of the core benefits you get from a function, and these are the benefits. You get the PayG because you're paying for compute time, and it costs a lot less. You don't have to pay for the resources. You get cross-language support for many programming languages such as .NET. We talk about that. You could use your Java, Python as well, or any scripting language you're familiar with that is available in the platform. You can write codes in the browser and you can respond to events from the HTTP request. That's what we just did. You have plenty of available pre-built templates. That's what we just used. You have support for continuous integration using function. Azure functions are scalable and you could use them on demand with no extra effort. And they support lightweight agility for your solution. So they're very quick, very agile. You could use them to help create microservices, really quick solutions to solve really complex problems. So they fit into the orchestration model as well. So there it is with Azure Functions and the benefits. So here are some of the use cases as well for Azure Functions. It's really a big part of the course, so you need to understand it. You could use it for scheduling tasks. You could also use it for reminders and notification. You could use it for lightweight web APIs and HTTPS protocols. And I want to emphasize something. You don't want to use functions for writing complex code. It's really for lightweight web API quick solution that you wanted to do. You could use it for sending background emails to customers and employees really quick, those type of lightweight solution. You could use it for running background backup services. Copy this folder to that location for me, please. That type of thing. You're doing backend calculations and decision real quick. You want to do a simple mathematical calculation. You could use function for that as well. So that's the concept behind functions. Now let's look at functions bigger cousin, which is Azure Logic Apps. So Azure Logic Apps operate in a similar manner as function in that it responds to triggered event. If you press a button, if you have a HTTP request, that can also be automated and can scale massively. The core difference include the fact that Azure Logic Apps is a member of the integration services, while function is a member of the compute class in the serverless computing. Okay, so one is an integration service. The Azure Logic app fits better into the continuous integration, orchestration, and continuous delivery pipeline in Azure, and it's used mostly for workflows. So they both have different usages as well. Now, further to that, Azure Logic apps are designed to empower scalable workflows. That's what I just mentioned, for a much broader integration model, such as business processes and enterprise orchestration, which is enterprise level automation across cloud formulas. So you could use it on premises and off premises. Azure Logic Apps also have much broader scope for services that transcend across on-premises and public clouds, making it an hybrid solution as well. So you're getting a good feel as to some of the fluid capabilities that you have with Logic App. Logic App is a little more than a service, but it's a complete platform that allows you to create, deploy, and manage mission critical automation workflows that integrates your application, your data, your services, and systems across cloud types. And it also, again, like I mentioned, helps with continuous integration and continuous delivery. So you'd use Logic Apps for enterprise workflow, large scale application. It's you can use it to execute much more complex tasks than you would with functions that are geared towards simple, lightweight tasks. This is for heavy lifting workflow processes, and it's part of your continuous integration process, and it's scope across platforms, which is part of your continuous delivery and integration as well. Now we're going to take a look at another solution in the entire DevOps in the entire Azure structure. We're going to be looking at Azure DevOps. So Azure DevOps is a full-scale unified solution created to solve technical isolation issues in software development lifecycle. I'll come back to that in a second. It fosters a better bond between developers, operations, business managers, and all other members of an organization. So DevOps was really created to solve a really complex and challenging issue in software development. Now, if you're a developer that works with a team in a large company, traditionally you would have a lot of bottlenecks when you have to create your code, and then you would have to write your deployment scripts like the functions we just did and hand it over to the ops team for them to do the deployment for you. Then you'd have to stick around in change management meeting and make sure that the changes go as planned, and then you would have to respond to any unforeseen matters that takes place while the rolling out is going on. So in situations like those, when something go wrong, there's a lot of finger pointing. The ops team would say it's your code. The code would say no, it's you. You didn't do it properly as I instructed. Microsoft takes a good look at that problem, and they come up with DevOps. And the word DevOps is really a synergy between developers and ops team to eliminate that barrier so that developer can deploy their own code and eliminate the need to have to wait on the ops team. At the same time, they could both collaborate and work in the entire DevOps ecosystem together as a team. So all members can participate in real time. So you have developers and the operation and business managers all participating, and they all have a feature and function within DevOps. So DevOps was created to solve that problem, and they are doing it with good orchestration in Azure. Now let's take a further look into DevOps. It gathers input from several teams, as you could see, for seamless collaboration is what I'm talking about. You get continuous integration, giving developers complete control over the entire software development lifecycle from ideation to sunset. So from you start thinking about the product until it's retired, you have support for it in DevOps. Now, DevOps foster a more agile and collaborative business environment in an organization as well. So you're able to follow a more agile business model. You're able to do things more aggressively. So rather than having developers working in a silo in the past, we did in the past when I gave an overview on their local machine, then pushing changes to version control system for unit testing by the ops team. All teams work more closely together at this level in the entire SDLC process, and the end result is less technical friction, less finger pointing, better communication, more on-time deliveries, no budget overrun, quality products, and they're finished on time the right way the first time. So it's a massive improvement from where we were coming from, where we are coming from as developers. So that is the history of DevOps. Now let's take a look into the toolbox. Inside the DevOps toolbox, you have a lot of tools in the pipeline. So DevOps toolbox is pretty familiar tools for both developers and operation teams from various platforms. So if you're coming from a Java background, a Microsoft shop, a Python shop, you're still going to find a lot of tools that will make you very happy in DevOps. You might be using Eclipse for Java, Visual Studio for .NET, Teams Foundation Server for your version control and collaboration. DevOps is well prepared for you to continue on that journey. So there are Git resource manager that you could use to manage your repositories. If you're building, you could also use Cradle to build out your application as well. So Azure have a lot of features built into the DevOps toolbox. You also have Azure Boards. Azure Boards provide software development teams with the interactive and customizable tools they need to manage your software projects. So it provides a rich set of capabilities, including native support for Agile model, Scrum, and Kanban model. So you're working with familiar processes, familiar model that you're used to in your development environment, except it's in a more seamless, more collaborative, and more straightforward manner. So there it is. It's a better integrated dashboard for you, Azure Boards, as part of your DevOps toolbox. Now let's look at the toolbox in more detail. The Azure Pipeline. This you could use for continuous integration and continuous delivery as well. It's an automatic build, automatical test, and deploy applications. All projects are available together. It works with just about any language or project type or project model, project management model. Azure Pipeline combines continuous integration and continuous delivery to test and build your code and ship it to any target. So you see, it's really, really powerful working inside DevOps. Now, continuous integration, I use the term quite a lot. It is really the practice used by development teams to automate the merging and testing of code, implementing and help to catch bugs early in the development life cycle, which make them less expensive to fix later on downstream. So that is a general overview of CI. Now let's look at CD. Continuous delivery is the process by which code is built, tested, and deployed to one or more test and production environment. Deploying and testing in multiple environments increases quality. CI system produces deployable artifacts, including infrastructure and apps. Automated releases processes consume these artifacts to release new versions and fixes to existing systems. Monitoring and alerting systems run continually to drive visibility into the entire CD process. So you get an idea of what continuous integration is and continuous delivery, and we'll talk about artifacts and packages that you would use in your development and how they fit into Azure. Next thing we want to talk about on a continuous fashion is continuous testing. On premises, you get that in DevOps as well. On premises or in the cloud, it is used to automate, build, deploy, test workflow with a choice of technologies and framework that test your changes continuously in a fast, scalable, and efficient manner. So as soon as you update something or you change something, it's getting retested in a continuous manner so you stay current and your code is easily fix if there's a bug or anything like that inside of it. So you get a general understanding of what your DevOps toolbox can do for you. Now, Azure Test Plans, it improves the overall code quality by using manual and exploratory testing services in your application so you can deploy them with high confidence, knowing that they're fully tested using your specific test plan in an automated manner. So that's your Azure Test Plan. Now, artifacts we mentioned briefly before, it's just test management for CI and CD pipelines. Azure Artifacts enable developers to share and consume packages from different feeds and public registries. So if you're used to NuGet or different package managers in Visual Studio or whatever language, it all integrates into artifacts and provide you with a broader platform. Packages can be shared within the same team, the same organization, and even publicly with others in repositories. So consider the Azure Artifacts as a packaging tool. If you're familiar with NuGet or any other command line packaging tool that you would use, Artifacts would help complement those services for you. Now, Artifacts support multiple package types such as NuGet, that's what I was talking about, NPM, Python, Maven, and universal packages. So it's a really fluid packaging solution. Remember it, Azure Artifacts, it's a part of your CI/CD solution for your testing, and it also helps you with package management. Azure Artifacts is built on a consumption basis, and it's free up until you use more than 2 GB of storage. Now let's look at Azure Dev Test Lab. It's also another powerful tool in the Azure DevOps. Azure Dev Test Lab is a service that enables developers to efficiently self-manage virtual machine and perform platform as a service resources, and this is key, without waiting for approval and budgets to do testing. So you don't have to wait for approvals and budgets. It allows you to quickly set up your test labs, a series of virtual machines using your virtual machine set. You could do testing, setting up your emulating your production environment, so you could create your virtual machines with your applications on it, and then you could go ahead and do your testings in a real rapid manner. So understand the purpose of Dev Test Lab. It is for developers, and it supports rapid testing of applications without having to waiting on a budget. Now, Dev Test Labs are Azure's resource manager template used for creating test labs with all the necessary tools and software needed for testing. So if you remember when we talk about Azure Resource Manager in the session before, it's really infrastructure as a code. You're able to create an entire infrastructure. Yes, you could create an entire testing environment with the resource manager as well in the Azure Test Lab, so it can help facilitate the needs you would have for testing. So by using Dev Test Lab, you could test the latest version of your application by doing the following tasks. Let's run through the tasks that you could do. You could quickly create Windows and Linux environment by using reusable templates and artifacts. The artifacts, again, remember it's your packages and solutions, so you could keep them around and reuse them, except you're going to get billed for them when you go over 2 GB. You could easily integrate your deployment pipelines with the Dev Test Labs to create on-demand environment. You could also use DevTest Lab to make it easier to control costs by allowing you to do the following tasks. You could set policies on your labs, such as the number of VMs per user per lab, so you could restrict the amount of resources that a particular developer could use. You could create policies to automatically shut down and start VM. You remember we talk about shutting down your VMs if you're going home on the weekend, so they're not running and incurring costs for CPU and memory time, so you only pay for storage. You could track costs on VM platform as a service resource by spinning them up inside the lab. Let they stay within budget. You receive notice of high projected costs for labs, so you can take necessary evasive actions. If you have a lab that's exceeding the resource requirement that you set for testing, you stay within the context of your labs, so you don't spin up resources outside of them. So you see, you have a lot of control and a lot of features that you could use in DevTest Lab to do your testing and make you a more efficient and productive developer. Okay, so we're gonna move on from DevTest Lab to GitHub. So you should be familiar with GitHub if you're an IT person. It's the most popular source control, version control management system in the marketplace today. It's an open source product and it's now owned by Microsoft. Microsoft incorporates it in Azure, so it's a multi-part source code and version control management system. The Git is the actual decentralized repository that store your source code and information and documents. The hub is the GitHub is the client-facing host that coordinates version control, collaboration, reporting, and documentation services to team member and organization. So you could use the GitHub for a lot of technical documentation, storing your documents. It's really leaps and bounds ahead of the competition as it relates to version control management systems on the market today. If you are a developer, you use GitHub. I can guarantee you that. Now, GitHub features include the following: share repositories for codes. You have code. You can do code reviews among peers to make sure that prerequisites are filed before code is stored in the repo. You don't save the code until you and your peers review it and make sure all the standards and coding notations are adhered to. Now, it accommodates project management tools such as Cabana boards. We talk about that as well. So if you're using a project management system, you can incorporate it for the most part into GitHub. But Cabana board is a really powerful and really good open source tool that most people are familiar with as well. You could also get reporting, live discussion, and tracking of your development inside the GitHub as well. You get GitHub includes wikis for collaborative documentation. So you could do a lot of documentation, share your documentation. There's a lot of services you could do, a collaborative service you could do in GitHub as well with your document. Now, you also can run GH from the cloud or on premises. So you could use it to cover both platforms as well. So that's GitHub. We went over GitHub. Let's take a look now at GitHub Action. And again, GitHub Action is part of your CI/CD workflow tool designed specifically for automating tasks. Now, in Azure, you could launch GitHub from Git Actions from inside Azure and inside GitHub. Git Actions allow you to create workflows to build, test, publish, release, and deploy codes systematically. So Git Action is really an automation tool, and once you see CI/CD, you know it's a part of complex orchestration problem solving that you are getting into when you see those two terms: continuous delivery, continuous integration. So Git Action allow you to create workflows and automate your deployment and testing tasks. It's a really powerful solution in Azure. So a workflow would be a collection of self-defined action of tasks that you want to perform on a particular solution. Now, Git Action has plenty support for core Azure services and resources. It supports Azure App Services for your application development, your web applications, so you could do automation with those. It supports functions that we just spoke about. You could automate your functions as well. You could test your functions there. It supports Azure Key Vault we spoke about for holding your secrets. It supports Azure Resource Manager templates. It supports Azure Client CLI interface if you're using Mac or Linux. It supports Azure Policy, which we will be talking about as well further down. And it also support graphical user interface editors, as is the case with the Azure Pipeline. So you get all of that with GitHub Action. It's similar to the Azure Pipeline, but it's more geared towards a Git setup. So if you're coming from a GitHub background where you're familiar with GitHub, this way you will be at home using the GitHub Action in Azure. Now, GitHub Action is probably the most used continuous integration solution in Azure. It is said that over 75 million jobs are run or managed monthly using Azure GitHub Action. So there are approximately over 7,000 actions on board in GitHub using GitHub Action. So understand that it's really a very powerful tool. Now, GitHub Action also use YAML as well. It's similar to XML. It's a format like a notation or a format that you could use. So you could use YAML file to deliver CI/CD solution from inside GitHub as well. So there's a lot of support for GitHub Actions inside Azure, and it's help with your continuous integration and continuous delivery processes. So you want to understand GitHub Actions as well and GitHub artifacts. Okay, so we are through with this particular part, this particular section. What we're gonna be doing, we're gonna be looking at Azure management tools next. We're looking at the solutions before, so we'll be looking at advisor, monitor, service health in a few. So let's just break for a minute, and I'll come back for the next session in Azure. Okay, again, my name is Everell Morris from NetMerge, and I'm your instructor for this Azure AZ 900 Fundamental course. So we are on part 3, and I'm going to be going over the second session in part 3, where we're going to be talking about the Azure portal, the Azure PowerShell, Azure CLI. Then we'll move on to talk about mobile apps in Azure. Then I'll be talking about the Azure Advisor, the Azure Resource Manager, then the Azure Monitor, and then Azure Service Health. So that those sums up the management tools that we'll be talking about in Azure. So let's get started by looking at the Azure PowerShell. Now, Azure PowerShell is the best choice for one-off, non-repeatable task in Azure Windows environment, or for someone with a Windows background who's familiar with Windows. So PowerShell runs on a Windows platform, and CLI would run on a Linux or a Mac or Android platform. So that is the Azure PowerShell. I just want to give you an understanding. We'll take a look at all of these collectively in the cloud in a few. Next, we want to look at the Azure client side. It is best a bash shell feature, and it's ideal for command line choices for user from a Linux, Android, Mac OS background if they wish to execute a one-off task in Azure. Now, if you want to do Azure mobile app, this is likely a good compromise to perform one-off management, administrative, reporting, action tasks for employee on the go or away from the office. So what you're seeing here is different way to execute or do different things. So this is a solution you would have if you're going out for lunch for 2 hours, or you just on the go for a particular reason. You want to use the Azure mobile app. It's not your standard or your routine office solution. Now, the Azure Resource Manager template, it helps in situations where an entire infrastructure as a code solution is needed. So if you want to deploy an entire infrastructure with new network, new virtual machine, say you open up a new office in a new state and you want to copy everything you have in an existing location, you would use your Azure Resource template to deploy that entire infrastructure for you using code. It's a lot more efficient, it's a lot more effective than doing it using the Azure portal. So that is your infrastructure as a code and the Azure ARMS template. We'll look at it more. Now, Azure Advisor makes cost reduction recommendation, and I want you to wrap your head around that. It's in red. Azure Advisor makes cost reduction recommendation around reliability, security, and performance, operational excellence in Azure. So operational excellence is at the core of the Azure Advisor Management Tool solution. You can accept, dismiss, or put off a recommendation, losing only the time on future optimization efforts. So again, remember what the advisor does. It recommends cost reductions and savings for you. Later on in the course, when we talk about cost management and cost management reduction, you will see the Azure Advisor comes up again. But you need to be able to differentiate it on the exam as well, what the use case scenario is for. You can configure alerts for recommendation in the Azure portal or through APIs. You can have a lot of control over the level of recommendation you need. You could get recommendation for critical stuff, for non-critical stuff. You have all the control you want in the world over that. You could set it as a subscription level. You can set it at a sub-subscription, at the resource level, at the group level. You have that configuration, that scoped configuration as well. Now, recommendations are available in five groupings for the Azure Advisor, and those are reliability. It applies to mission critical application for excellence and continuity. There's a couple things we talk about for reliability, including region pairing, which we spoke about before, and you understand the concept for that. We also talk about availability zones and how you would duplicate data in the particular zone as well. And you understand that. You understand zonal storage, LRS, ZRS, GZRS, and all those type of storages that contributes to reliability. So you understand that. Security, detect threats and risk and try to mitigate them. You understand that. Performance, quality, experience, and service speed efficiency. You understand that with low latency and all those different types of services as well. You understand cost, it used to curtail waste and budget overruns. You get recommendation and what you should do with resources if you're not using a virtual machine from the Azure Advisor. So that is a part of the overall solution. And finally, operational excellence for efficiency around resources, best practices, so you're able to use your resources in the most efficient manner as well. So that is your Azure Advisor, and I give you a good overview as to what the Advisor is used for in Azure. Now let's take a look at the Azure Monitor. Azure Monitor works on an entire organization to capture, analyze, visualize, and based on information gathered on and off premises. So it works across platform for you as well. So it gives you a general overview of both your on-prem and Azure Cloud Service solution. This is a general overview of what your Azure Monitor would look like. It's a global view, it's scoped, so you get everything log, your matrices and your logs in the center. So it monitors your application, your operating system, all your resources, all your subscriptions, all your tenants, and custom sources that you're using. And as you could see, it would do insight into your application, your containers. You get visualized dashboards and views, Power BIs and workloads that you can look at. It's able to analyze, it's able to respond to alert, and it's able to auto scale. It's able to integrate with Logic Op and export API. So you get an understanding of how powerful your Azure Monitor is. It's a global scope that you can use to capture, analyze, and visualize information in Azure. Okay.